Hello friends and welcome to CEC live lectures. In the previous few lectures we have discussed about certain important classes of plant secondary metabolites like alkaloids, flavonoids, volatile oils, terpenoids. So in continuation with the series, today I am going to discuss with you another important class of plant secondary metabolites, that is tannins. Now in this presentation we are going to learn about what are tannins, how they are distributed in the plant kingdom, what are their various properties, and on the basis of these properties how they are classified into different categories or classes, then how they are extracted from the plant matrix, and after that we will learn about the various chemical tests that are being utilized to detect the presence or absence of tannins in the plants or in the given sample of the plant material. And in the end we are going to discuss about various uses, both therapeutic as well as non-therapeutic uses of these important secondary metabolites. Now the tanning process is a process by which the animal skin is converted into leather, and this process is being utilized since 1500 BC. The person who used to perform this process is known as tanner, and one school of thought believes that since the person who performed this process is known as tanner, the substances that are being utilized in this process should be named as tannins. So this is one I will say hypothesis by which the term tannin was generated. Another school of thought says that tannin has been generated from a German word tanna or a Latin word tannere, which has been in turn generated from tannum. Now these terms tanna or tannum has been given to oak tree, and these are the trees that belong to the genus of Quercus genus. Now previously the bark of these trees was mainly used for the tanning process, and in this picture, though it's slightly distorted, you can see that people are scraping off the bark from oak tree, and this bark is then being dipped in water to prepare its aqueous extract, and that aqueous extract is being utilized for the tanning purpose, wherein the skin of the animal is dipped in that tannin or the aqueous extract, and the tannins present in that aqueous extract react with the skin and convert it into leather. So these are the etymological I will say examples how the term tannin was generated. But earlier the term tannin was not used until the end of the 18th century, that is 1796, when Armand Seguin gave the actual term, that is tannin. And according to Seguin, tannins are the polyphenolic compounds which are having astringent action, and now we know that astringents are being largely used for tightening up of the skin or for the wound healing purpose, because they have a tendency to precipitate the proteins, and that is why the astringent action is an important character of these secondary metabolites, that is tannins. Now the question is how these tannins react with the skin of the animal, or we can say that how these tannins convert the animal skin into leather. Now we all know that the major protein present in the skin is collagen, and it is present in both crystalline form as well as the amorphous form. Now these tannin compounds, they are polyphenolic, therefore they have numerous hydroxyl groups present in their structure. So when these tannin compounds enter into these amorphous region of the collagen fiber, which is having intracellular spaces, so these hydroxyl groups form bond with the active site of that amorphous collagen fiber. Now these active sites are nothing but these are the peptide bonds that have not formed any kind of bonding with the internal structures. So in other words, we can say that these peptide bonds are free. So that is why these hydroxyl groups, they form bond with these active sites or the free peptide bonds. Now once these bonds are formed with the tannin compounds or the hydroxyl group of the tannin compounds, these tannins further start getting polymerized, because some of the hydroxyl groups still remain free, and these free hydroxyl group of the tannin groups of the tannin compounds, they start forming bond with other tannin molecules, thereby causing the polymerization of that particular complex. Now, as the time passes, these polymerization complexes increase in size, and gradually they fill up the free intracellular space that is present in the amorphous collagen fibers. And once these intracellular spaces are filled, empty spaces are filled, the animal skin get hardened, and gradually it gets converted into leather. So this is basically how the tannin converts the animal skin into leather. Now, various definitions then were given about these complex molecules. Bates, Smith and Swain defined tannins as the water-soluble phenolic compounds with a molar mass between 300 and 3000 Daltons, showing the usual phenol reaction like blue color with ferric chloride and precipitation with alkaloids, gelatins or proteins or heavy metals. Now, why this emphasis on molecular mass is given, that is 300 to 3000, because it has been observed that if a molecule is small enough, though it will enter into those amorphous intracellular or empty spaces, but it will not be able to polymerize with other tannin molecules. And once that small molecule will not form any kind of polymerization, it will not lead to the conversion of skin into leather. Vis-a-vis, if a tannin molecule is large enough that is its molecule weight is far beyond 3000, then what will happen? It will not be able to enter those intercellular spaces in the collagen fiber, and the whole process will not occur. That is why a lot of stress is being given on the molecular weight of these compounds. But gradually, as the understanding about these important compounds improved, the definition also improved. Griffith defined tannins as macromolecules, molecular phenolic substances, and divided them into two major groups, that is hydrolyzable and the condensed tannin. Another definition states that tannin are the C or O glycosidic derivatives of gallic acid. Now, all these definitions are complete, or I will say incomplete in one sense or other, because in some definitions you will not see the emphasis given on the molecular weight. In some definitions you will see that all the classes of tannins are not covered. Say for example, in the last definition it states that C and O glycosidic derivatives of gallic acid, it does not covers the condensed tannin category, whereas the definition given by Griffith, it states that they are macromolecular phenolic substances, but it does not give any emphasis on the exact molecular weight. So these definitions in one sense or other were incomplete. Now, Karmali, Khanababi and Tannins van Rie, they give a very comprehensive definition of tannins. Now, according to them, tannins are the polyphenolic secondary metabolites of higher plants and are either galloyl esters and their derivatives, in which galloyl moieties or their derivatives are attached to a variety of polyol, catechin and terpenoidal core molecules. So this part covers both classes, that is gallotannins and elagotannins, as well as the complex tannins. Further, or they are the oligomeric and polymeric proanthocyanidins that can possess different intraflavanile coupling and substitution patterns. Now, this portion of this definition cover the condensed tannins. Now, that is why I said it is the most comprehensive definition of tannins, because it is covering each and every aspect of the tannins. Though well-defined molecular weight has not been mentioned in this definition, but one can easily correlate when we study about the derivatives of galloyl moieties or proanthocyanidins, that the molecular weight will be having a specific value. But still, molecular weight aspect is missing in this definition as well. But still, it is a more comprehensive definition than the previous ones. So, if we want to simplify this definition, we can state that tannins are complex polyphenolic water-soluble secondary metabolites from higher plants which have a molecular weight of 500 to 3000. More appropriately, I will say 1000 to 5000 and above, because recently it has been seen that certain condensed tannins have a molecular weight up to 20,000, and they have shown the possibility of converting animal skin into the leather. And they have an astringent action, which is another important characteristic of tannin, and can be categorized into hydrolyzable, condensed, which are also known as polymeric flavin derivatives, pseudotannins and complex tannins. So this is the simplified version of the previous definition, and one can easily remember this definition. Now we move on to the distribution of these tannins, and if we look into the distribution, they are widely distributed in the nature, and specifically if we talk about plants, they have a very wide distribution in the plants, and they are found in almost every type of plant. And within plant, if we look into different parts, tannins are present in almost every part of a plant. Say for example, tannins are present in the barks of cinnamon or wild cherry, cinchona, acacia. Oak is a traditional example. Then in case of rhubarb and male fern, the tannins are present in their roots and rhizomes. Tannins are present in the flowers and buds of clove, lime, rose petals or hawthorn. They are also found in the seeds of coca or cola or areca. Then in case of fruits, they are found in myrobalan, which is also known as harad or haritaki in Ayurveda. Then cranberries, grapes, specifically in case of red wines, where tannins which exhibit a non-pharmaceutical, non-therapeutic use of tannins, wherein they are largely used to improve the flavor of these wines. Then tannins are also found in leaves such as hemimalice, or especially in case of green tea where a lot of catechins are present. Then you will also find tannins in certain extracts or dried juices of catechu or acacia or Indian kinu. So you can see that tannins are present in almost every part of a particular plant. Now coming on to the properties, and as we have discussed in the definition, that these are the polyphenolic compounds. And why polyphenolic? Because they have lot of hydroxyl groups in their structure, and since they have lot of hydroxyl groups in their structure, they are quite polar in nature, and therefore they are more soluble in water or dilute alkalis or alcohol, glycerol or acetone. Now they appear as light yellow or white amorphous powders. That powder can be shiny in nature or simply amorphous, and they occur as loose masses when they are isolated or extracted from the plant material. They occur as loose masses. As we discussed that majority of the tannins, they have a molecular weight between 1000 to 5000 Daltons, and they have an astringent action, which we have discussed in the definition also. And because of their polyphenolic nature, they have a tendency to precipitate proteins, alkaloids, gelatin and heavy metals. Now since they have a tendency to precipitate the heavy metals, they basically gives a false positive test when they are present, and when we are testing for the presence or absence of alkaloids. And if you remember my previous lecture on alkaloids, there I discussed about the false positive test because of false positive test of alkaloids because of presence of tannins. And besides all these, tannins can also occur in combination of sugars, that is as glycosides. Now coming on to the classification of these secondary metabolites, that is, they are classified into true tannins, pseudotannins and complex tannins. Now true tannins are further categorized into hydrolyzable and non-hydrolyzable or the condensed tannins. Now hydrolyzable tannins, as their name indicates, they have a tendency to get hydrolyzed whenever they are treated with an acid or an enzyme. Basically these hydrolyzable tannins are also, or rather I will say, were also known as pyrogalol tannins, because it was observed that gallic acid, whenever it undergo dry distillation, it gets converted into pyrogalol. Therefore these were known as pyrogalol tannins, but now more likely they are known by the name of hydrolyzable tannins. Now these hydrolyzable tannins, they are formed by either gallic acid units or by hexahydroxydiphennic acid units, and this forms the basis of the further classification of hydrolyzable tannins. So we can say that hydrolyzable tannins are categorized into gallotannins and elagitannins. This is the general classification of tannins. Lot of scientists have given various classifications of tannins, and amongst all those classifications, Haslam's and Okuda's classifications are generally more acceptable. And according to their classification, gallotannins fall under group A or type 1 tannins, whereas elagitannins are further categorized into two different categories. One, category belongs to those tannins that are the hexahydroxy diphenyl type of elagitannins, that is group B or type 2 tannins, and the second category of elagitannins is the dihydrohexahydroxy diphenyl type of elagitannins that form the group C or type 3 hydrolyzable tannins. Coming on to gallotannins, or we can say group A or type 1 of tannins. Now, since these are the hydrolyzable tannins, gallotannins are those tannins which on hydrolysis give a gallic acid unit or the gallic acid moiety. Now, if we broadly look into the structure of gallotannins, it is having a polyphenolic moiety as well as a polyol moiety or the sugar moiety, which can be glucose or mannose, but generally it is a D-glucose structure. Now, these are characterized by the presence of dipsidical arrangement of galloyl units that are linked to the hydroxyl group of the sugar molecule. And this arrangement of galloyl units with the sugar molecules, this lead to formation of two core structures. One is 1,2,3,4,6 beta penta O-galloyl D-glucopyranose core molecule, that is PGG, and second one is 2,4,6 tetra O-galloyl D-glucopyranose, that is TDG core molecule, and amongst these two, PGG is more prevalent in comparison to the TGG in the nature. So, in PGG, 5 galloyl or I will say gallic acid units are attached to the hydroxyl groups of the central glucose molecule or the sugar molecule, and a tannin or I will say and a molecule to be categorized as a tannin or a hydrolyzable tannin, 3 hydroxyl groups should be esterified with the gallic acid molecules. Only then that molecule can be considered as a tannin. This is one of the another character of specific character of these hydrolyzable tannins. Now, these are the few examples where you can find gallotannins. One is rhubarb, Rhizum officinalis, hamamelis. You can see the flowers of hamamelis. Then clove, which is known as long or Eugenia carophyllus. Then Turkish galls, Quercus infectoria. Galls are nothing but these are the tumorous outgrowths that are due to the infection of bacteria or fungus on the plant. Then you will also find these gallotannins, pomegranate bark and the Chinese galls. Now, coming on to the elagitannins, which constitute the which are further categorized into group B and C or type 2 and 3. Now, this is considered as the largest group of tannin, and it has been found that these elagitannins are generally produced with the help of gallotannins, and normally what happens is two gallic acid units, they condense to form a hexahydroxy diphenyl unit or hexahydroxy diphenic acid. Now, this diphenic acid undergo polymerization and it leads to the formation of elagitannins. Now, why they are known as elagitannins is because this when these elagitannins they get hydrolyzed, they give rise to hexahydroxy diphenic acid unit, because you can see in the slide two galloyl units they condense to form hexahydroxy diphenic acid. These hexahydroxy diphenic acid further polymerize to give rise to elagitannins, and these elagitannins on hydrolysis give back a hexahydroxy diphenic acid molecule which undergo lactonization to give elagic acid, and that is why these tannins are known as elagitannins, though we can consider elagitannin as a misnomer because on hydrolysis elagic acid is not produced, but it is produced only after lactonization of hexahydroxy diphenic acid. Then we have these are the examples of type 2 or we can say that hexahydroxy diphenyl type of elagitannin, and type 3, that is dihydrohexahydroxy diphenyl type of elagitannins. And you can see in type 3 the one of the rings in the hexahydroxy phenaic acid, it is having a ketonic group, and it is having more saturation in comparison to hexahydroxy diphenic acid molecule, which is shown in the left side of this structure. Now, these are the examples of the plants which are having elagitannins, and the most common example is the wild cherry bark, which is obtained from Prunus seratona, and you can see the example of the picture of this bark. Then myrobalan, that is Terminalia chebula, or the fruits of Terminalia chebula, which are known as harad or Malabar kinno. All these are the plants which are rich in elagitannins. Now we move on to the non-hydrolyzable or the condensed tannin, and as their name indicates, these tannins are not hydrolyzable. They do not get hydrolyzed by water or acids or enzymes, and that is why they are also known as condensed tannin. And another difference from the hydrolyzable tannin is that they do not have any sugar molecule in their structure, whereas the hydrolyzable tannins were having a central glucose or mannose molecule in their structure. Now, the non-hydrolyzable and condensed tannins, these are considered as the polymers of flavin-threol molecules, and that is why, since they are polymers of flavin-threols, they are also known as proanthocyanidins, because when they are exposed to strong acidic condition, they break down into flavin-threol molecules, and that is why they are considered as proanthocyanidins. Now, these molecules, they yield catechol when they undergo dry distillation, and therefore these are also known as catechol tannins. Now, tannins with 2 to 10 catechin units, they are also known as flavolens. So, if these are having 2 to 10 catechin units, they are also termed as flavolens, and they have a lot of structural diversity due to substitutions on the hydroxyl groups, as well as difference in the position of the linking of these units. As you can see that they have a linkage. Generally, they have a linkage of 4 to 6 or 4 to 8 between the two flavin-threol molecules. And these commercial tannins have a wide commercial usage than the hydrolyzable tannins. Whenever these are treated with acids, strong acids or enzyme, they get converted into red insoluble compounds, which are known as phlobaphene, and these compounds are responsible for the red or reddish brown color of certain drugs like cinchona bark or quebracho tree bark. And these are the examples of the plants with condensed tannins, and cinnamon, cranberries, and specifically tea. These are the common plants that are rich in these condensed tannins. So, friends, this was about the classification of tannins, definition of tannins, and their distribution. And in the next lecture, we will discuss about the other classes of tannins, that is complex pseudotannins. Then we will discuss their extraction and uses. Thank you.